Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Equality Cages 143, Region SumDrone by Gubler and Jarlemus, sorry. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in each empty cell, and digits must not repeat within the same row, column, or box. We have equality cages. Cages must have an equal number of low digits and high digits, and an equal number of even digits and odd digits. So the low digits in this case are 1 through 4, the high digits are 6 through 9, and the evens are 2, 4, 6, 8, but the odd digits are 1, 3, 7, 9. Equality cages can never contain a 5, and digits may not repeat in a cage. Well, they couldn't repeat anyways because of just normal Sudoku rules. But these cages have an equal number of low digits and high digits, and an equal number of even digits and odd digits. And that's how equality cages work. We have crop key dots, where a black dot between cells indicates cell values with a 2-to-1 ratio. And not all dots are shown. So, for example, if this were, say, a 2, this would have to be a 1 or 4 to maintain the 1-to-2 ratio between them. And that's an example of how crop key dots work. We have adjacent cells connected with an x must sum to 10. Not all x's are shown. We only have the x here. So if this were, say, 3, this would have to be 7, because these two digits must add up to 10, because there's an x between them. And finally, we have region SumDrone, where digits along lines have the same sum within each box the line passes through. In addition, so these two digits must sum up to the same sum as these three, which sum up to the same sum as these two. In addition, each segment defined by the box borders equidistant from the center must have the same digits in any order. Okay, I'm not sure. So, for example, if row 6, column 8 was a 2, and row 6, column 9 was a 6, row 7, column 7 would have to be an 8, and row 8, column 5, and row 6, column 6 would be 2, 6, or 6 and 2. Okay. Got it. Okay. So the reason why this works is, so if, say this was 2 and 6, that works because the digits on the segments equidistant from the center, so this is the center of this region SumDrone line. So this segment is equidistant from as this segment. So these must have the same digits along this region SumDrone line, and they must add up to the same sum as all the other segments, right? So 2 and 6 adds up to 8, so therefore this is 8 adding up to 8, and this is 2, 6 adding up to 8, and these digits must be the same. So for example, on this region SumDrone line, these 3 digits must be the same as these 3 digits, and these 2 digits must be the same as these 2. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So these two digits are exactly the same as these two. These three are exactly the same as these three. Well, we know these three cannot be the same. I mean, they are the same as these three, so they cannot be the same as these two, which are these two digits. So either all three of these are the same. It cannot be both of these two are exactly the same. So these three digits must be the same as at least two of these digits. So actually, these two digits and one out of these two. Interesting. We know, okay, so for equality cages, equal number of low and high digits, equal number of even and odd digits. Well, we know whatever these 10 are, they must be the same parity. So they're both even or they're both odd. Well, we know we either have in the 1 to 2 ratio, one odd and one even, or two evens. Since we know these are the same parity, and we have to have equal number of odds and evens, this has to then be the same parity, and these must be the opposite parity. So these must be both even, and these must be both odd. In addition, one of these is guaranteed to be high and one's going to be low, so this must be high and low. In which case, this must be 4 and 8 to be one low and one high in a 1 to 2 ratio. Because the other high that can be in a 1 to 2 ratio would be with 3 and 6, but then you'd have 3 odds here. And this must be either 1, 9 or 3, 7, adding up to 10. Okay. 9 cannot be here. Actually, 9 could technically be here. This is one odd and one even. This is one odd and one even, and they're the same digits as these. And they have to be in a 1 to 2 ratio. So the only one that fits that criteria is 3 and 6. So this is a 3-6 pair. This is 3 and 6. Because we must have one low, one high, one odd, and one even. And they must be in a 1 to 2 ratio. So that's why these are all the same. Therefore, this adds up to 9. So this cannot be 7 or 9 here. And this can't be 1 or 3. This is either 1, 3, or 5. Or 1, 2, and 6. Cannot be 2, 3, and 4. So we're guaranteed a 1 has to be one of these digits. So it could be 1, 3, 5 or 1, 2, 6. We're guaranteed. That means either this is 3 or this is 6. And this is 3 or 6, which eliminates 3 and 6 in the rest of the row. So the rest of the row has to be not 1, 3, or 6. So it's 2, 4, 5, 7, 8, 9. 5 cannot be on any of these equality cages. That means for the low in this equality cage, it has to be an even low, which means we need an odd high digit to be with it to have an equal number of low high digits, right? We have a low already, which is even. We must have a high digit for the other digit. And since they're both even, the other one has to be odd. So that's the pairing here. We must have one odd and one even here, and it adds up to a single digit. And we have a low and a high. So this is at least 7. This could be 7. It cannot be 8. because one of these is odd, one of these is even, therefore that adds up to an odd number. So this is 7 or 9. And in fact, the high digit here has to be at least 7. So therefore this must be 9. So therefore we know this is 7 and 3 to add up to 10 because we can't have 1 9 anymore. Therefore this is 1 and 5 as a pair, which eliminates 1, 3, and 5 in the rest of the row. This can't be 3, that's 6, which eliminates 6 here, so that's 3. Again, these cannot be 5 anymore, and this can't be 5. So this is either, it can be 2, 7, it cannot be 4, 5. It's 2, 7, 1, 8 are possibilities. 1, 2, 7, 8 here, because we can't have 3, 6 because of the 3, 6 pair in the column. So this is 1, 2, 7, 8 because it matches the digits as these. Okay. This can't be 9, it cannot be 6 or 3. So this has to be 4, 5, 7, or 8. We don't know. Remaining digits in box 2 are 2, 6, and 9. So this is 2, 6, and this is 2, 6, or 9. So 9 has to be one of these two digits here. This can't be 8. And since this can't be 8, this can't be 1 to add up to 9. uh. These two are the same digits as these two. Obviously, it's the sum of two digits. And, one of them has to be low. So that means they add up to at most 13. They must be equal to the sum of 3 digits. And it includes 1 and 6, so it's at least 7, but if it's 7, that would be 1, 2, 4 here, which would eliminate all possibilities, adding up to 9 here. So it could be 8. So the sum is either 8 to 13. It can't be 8. We have 4 unique digits here, which add up to the sum. So it's 10 to 13. So these must add up to 10 to 13 here. That means I think we're guaranteed a 1 here, right? The minimum for digits without a 1 would be 2, 3, 4, 5, which adds up to 14, which is greater than 2 digits in the equality cages can add up to, right? You have at most 4 and 9. So can you ever have a 1 here, I guess? No, 1 and 9 adds up to 10, but you don't have equal amounts of odd digits and even digits. So that means this has to be at least 11. Well, yes, it must be at least 11. Because if you didn't have 11, again, there's one odd and one even digit in this segment, which adds up to an odd sum. So it's either 11 or it's 13. So we're guaranteed this has to be 1 through 7 because of the digits. That means this cannot be 9 here. This has to be 9 here. And you can't have 1 and 2 here. Because if you did, that would eliminate all possibilities for these digits here. So this must be 1, 3, 4, 5, adding up to 13, which makes this a 2, 8 pair, which makes this 4 and 9 to add up to 13, because that's the only way you have an even and an odd and a low and a high digit to add up to 13. So that eliminates 4 from being here. It eliminates, cannot be 3. So this must be a 4 here. This is a 4, 9 pair here. And these add up to 13 without 3 and 6. So this is a 2, 7 pair. It also cannot have 2 and 7. So this can't be 2 or 7 here. That forces this to be a 4, 9, 4, 9 pair. Without 2, 3, 6, and 7, we have to add up to 13. And we have to include 4 or 9, but not both, obviously. Remaining digits of column 3 are 1, 5, and 8. I think 1 has to be part of it, though. 13. Could be 3, 4. It can't be 3 and 6. Right. No 2 or 7. So the remaining digits we have are 1, 4, 5. So if we try to have no 1, that doesn't work. Because 4, 5, and 8 would be the minimum then. We know we can't have 9 either, right? 9 can only be with 1 and 3 to add up to 13, and we can't have a 3 because of this 3, 6 pair here. So this can't be 9. This can't be 9. Where is the 9 in box 7? It must be here. And we know 3 and 6 have to be here because 3 and 6 can't be on this line because they match. These cells must match these cells in some way for the digits. So this is a 3, 6, 9 triplet. This can't be 9. That eliminates 3, 6, and 9 in the rest of the column. This can't be 9. This is 4, which means this can't be 4. That's 9, which eliminates 9 here, so that's 4. And 4 has to be with 7. Cannot be 9 here because of the 3, 6, 9 triplet in the column. And we need an odd high digit, so this is 7. So no 4, 7 here, no 4, 7 here, no 4, 7 here. This 1, 3, 5 triplet eliminates 1, 3, 5 in the rest of the row, so this can't be 3. This is 6. This is 3. That means this can't be 1. We have a guaranteed of 1 and 4 here. That adds up to 5. 13 minus 5 is 8. So this is 1, 4, and 8 here. Which eliminates 1, 4, and 8 in the rest of the box. This can't be 8. This is 5, which eliminates 5 in the rest of the column. That means this can't be 8 here. This can't be 5 because of 5 in the row. Remaining digits in box 5. We have 6 and 8. Okay. Remaining digits of row 4. We have 2, 7, 8. And obviously this can't be 7. 8 cannot be on the line, so this can't be 8 here because of the 1, 8 pair already there. Remaining digits of column 2. We have 1, 2, 5, 8. I think that's it. All right, 1, 2, 5, 8. 1, 2, 5, 8. This can't be 1 or 8. This can't be 1 or 8. We have a 2, 5 pair. in column 2, which eliminates 2 and 5 in the rest of the column. This can't be 2. This is 8. This can't be 2 or 5 or 8. It's 1. So 8 eliminates 8 here. This 2, 5 eliminates 2 and 5 in the rest of the box, so this can't be 2. That's 9, which eliminates 9 here and 9 here. This can't be 2 on this region's SumDrone line, because we can only have 1, 4, or 8 there, so this is 8, which makes this 2, and this is 1, 4 as a pair here. Remaining digits of column, or box 1, we have 3 and 6. This can't be 3 because of 3 in the row. So this is 6, which makes this 3. We have 2, 5, and 7 remaining in column 1, and this 7 has to be on the line because of the way the SumDrone works. This can't be 6 because of 6 in the row. Remaining digits of box 3 are 5, 7, 9. Okay. This can't be 7 because of 7 in the row. This is a 2, 7 pair, which eliminates 2 and 7 in the rest of the row, so this can't be 2. This is 5, which eliminates 5 here. So this is a 2, 7 pair, which means this is 7 and 2 here. Therefore, this is 5. 2 eliminates 2 here, so that's 9, which eliminates 9 here, so it's 5. Which means this can't be 5, this can't be 5, and this can't be 9. Okay. One of these is high, so it's either 6 or 7. And we have one low, which we don't know. It's 1, 2, 3, 4. It cannot be 2 here. If this is 2, it would have to be with a high odd digit, which can only be 7 remaining. So this can never be 2. 4 would be with 7, but that's fine. And we are guaranteed a 6 somewhere in column 5 here. So one of these is 6. So if this were 6, it would have to be with 1 or 3. That would, this can't be 4 either. So the only low digits here are 1 and 3. Because if we tried 2, that would force this to be 7, but then 2 would have to be with another high odd digit, which could only be 7 or 9, but we can't have 9, because 9 in the column. So this must be a low odd digit, which is 1 or 3, with a high even digit, which is 6. So this can't be 7. That means the remaining digits then are 2 and 7, because we have a 1, 3, 5, 6 quadruplet in column 5. Okay. This is in a 1-2 ratio. It cannot contain 3 and 6. 4 has to be one of these 3 digits remaining in column 6. So this has to be 1, 2, 4, or 8, because if it's 3, 6 as a... We know 6 can't be here because of 6 in the box having to be there. So 1, 2, 4, or 8. 8 cannot be on the region sum line because this can only add up to 8 at most. This cannot include 4 on the region sum line because of the 4 already in this row here. So this can't be 4, which means this is 1 or 2, which has to be in a 1 to 2 ratio with 1, 2, or 4. So this cannot be 8. We're guaranteed this is either 1, 2, or 2, 4, which eliminates 2 in the rest of the column. This can't be 2, it's 7, which makes that 2. This can't be 2, so it's 6, which makes that 2. 6 eliminates 6 here, so that's 8, which makes this 6. Okay. And remaining digits on the line cannot be 2 then. So this can't be 2, it has to be 1. Which means that's 1 and 2, which eliminates 1 here. So this is 3 and 6 as a pair, which eliminates 3 and 6 in the rest of the column. 2 eliminates 2 here. So this is 7, which makes that not 7, so that's 2 and 7. This cannot be 1 and 6 because of the 6 in the row, so this is 1 and 3, which makes this 6, which makes this 3. This can't be 3 in any of these spaces. So this is a 1, 3 pair, which leaves this digit as an 8. And this must add up to 4. 1 and 3 add up to 4, so this can't be 4 here. Remaining digits in row 7 are 1, 7, and 8. And 8 cannot be here because of 8 in the column. 4 eliminates 4 here, so that's 9 and 4, which eliminates 4 here, so that's 1 and 4. This one eliminates 1 here, so it's 8 and 1. 8 eliminates 8 here, so it's 4 and 8. This 9 eliminates 9 here, so it's 7 and 9. Here we're missing a low digit and a high digit. And the low digit cannot be 1, 3, or 4, so it has to be 2, which means this can't be 2. So this is 2. We have to have a high odd digit to match. And therefore it can't be 7, it must be 9. So this is 9, this can't be 1. This has to be 4 because of where it is. 1 eliminates 1 here, so it's 5 and 1, which eliminates 1 and 5 here. It's 3. This 1 eliminates 1 here, so it's 5 and 1. This 9 here eliminates 9 here, so it's 6 and 9. No 1 available here. No 4 available here. Remaining digits in column 7 are 1 and 5. This can't be 1 because of 1 in the row, so this is 5, which makes this 1. This 1 eliminates 1 here, so it's 3 and 1. Which eliminates 1 here, so it's 7, which eliminates 7 here. So that's 8, which means this can't be 8. That's 1, which makes this 8, which makes that 4. This 7 eliminates 7 here, so it's 2 and 7 and 2. Which makes this remaining 6 and 7. This can't be 7 because of 7 in the column, so that's 6, that's 7. That leaves the remaining digit as 6 in column 8. We have 3 and 5 remaining in column 9. This can't be 3 because of 3 in the row, so this is 5 and 3, which makes this 8 and 5. And we celebrate. There's 2 3s in the corner. We celebrate because we solved the puzzle. Interesting rule set. It is pretty restrictive. And it kind of reminds me a little bit of like palindromes. It's interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.